everyone. So in this video, we're going to be going over the properties of bases. So again, to recap, acids, bases, and salts are electrolytes. And electrolytes are substances that when dissolved in water, they basically dissociate into ions. And again, ions are charged particles. So because they dissociate into ions, they can conduct electricity. In this video, we're going to be focusing on bases. Now, bases, by definition, will release an OH ion, which is also called the hydroxide ion, in water. And the reason why it's called the hydroxide ion is because it has one oxygen and one hydrogen. Now, atom that is in a ionic form. Now, this is a negatively charged ion. And if we remember, acids, what defines an acid is that they release an H+ ion in solution, and the hydrogen ion in that case is positive. Bases, in this case, release an OH- ion, and in this case, it is negative. Now, if we're looking at the molecular formula of a base, it starts with a metal. So metals, again, we're looking at group 1, which is our alkali metals. Anything in group 2, which is our alkaline earth metals. And metals in group 3. Now, this is actually the reason why our group 1 and group 2 are called alkali and alkaline earth, because another term for looking at how strong of a base you are is the alkalinity of your solution. So that's where the alkali comes from. So if we're looking at examples of common bases, so we have lithium hydroxide. When it is dissolved in water, so when it's dissolved in water, it breaks up into the lithium ion, so Li+, and our hydroxide OH-. Another common example, sodium hydroxide, NaOH. Same thing, when it is dissolved in water, it breaks up into Na+ and OH-. Another example that we might see is calcium hydroxide. When it is dissolved in water, it dissociates into calcium and 2 OH-. So the key thing that we'll notice, and we'll see time and time again, that when it is dissolved in water, it has an OH- group that is also being dissociated. So all bases will start with a metal and end with an OH group. There is one key exception, and this is important to know. And the exception is ammonium. So ammonium is NH4OH. It's basically the only base that does not start with a metal, because when it is dissolved in water, it breaks up into the ammonium ion, and it still has your hydroxide ion as OH-. So moral of the story, bases, they release a hydroxide ion when they are dissolved in water. All bases except for ammonium starts with a metal and ends with an OH group. So what we're going to do now is we're going to look at the tests that we can do to determine if we have a base. So our first key test, and this is a test that you've seen time and time again, is litmus paper. Now, if we recap with acids, so we remember for acids, the red paper stays red, and the blue paper turns red. Now, for bases, the reaction is somewhat different in the sense that our red litmus paper turns blue. So as you can see, our red litmus paper, when we place it in a base, the red paper turns blue, and our blue litmus paper stays blue. So for bases, the red litmus paper turns blue, and the blue litmus paper stays blue. Just like I mentioned in the video on the properties of acids, the color change of the litmus paper only tells you that you have a base. It doesn't tell you how strong or how weak of base you have. And if you're trying to figure out the strength of the base, you would probably want to use pH paper, which is the next test that we're going to be looking at. So pH paper, Hydrogen paper, it basically can turn a variety of different colors. So if we're looking at a base, it will turn any of these colors here. Because again, if we're looking at a base, the pH of bases is anywhere between pH 8 to 14. So my color ranges, if it is green, and when we're talking about green, we're talking about dark green, it means you have a relatively weak base. So we're looking at pH 8 to around 10. If I have turquoise, we're looking at around pH 11. And if I have blue, that can be anywhere between pH 12 to 14. So with our Hydrogen paper, again, not only does the color change tell us that we have a base, but it also tells us what the pH level of our base is. Our last test that we can figure out if we have a base is that bases will conduct electricity because bases are electrolytes. So what we're going to do right here is we're going to look at our video where we have our electrical conductivity meter and we are going to be putting it in a base and we're going to see what happens. And we can see that when we put our electrical conductivity meter in a base, our light turns on. So electrical conductivity meter. In a base, our light turns on. So basically, electrical conductivity meter, it's basically a light bulb that's attached to a battery and it has basically two wires. So when we put it in our electrolyte, the electric current travels through the liquid and basically allows the light bulb to turn on. So for a base, because it's an electrolyte, it will conduct electricity and our light turns on. So to recap, we have three key tests to indicate if we have a base. Our first test, and pretty much our most reliable test, and this basically tells us if we have an acid, a base, or a salt, or a neutral product, is our litmus paper. So our red litmus paper will turn blue. Our blue litmus paper will stay blue. Now, again, litmus paper doesn't tell us the strength of the base, just that we have a base. The next test that we have is our pH paper, and we have a variety of color changes, and those basically tell us whether we have not only a base, but if I have a strong base or a weak base. And then last but not least, it will conduct electricity because, again, bases are electrolytes. I hope this helps, and I hope you have a great day.